The topic of this video is adding and subtracting unlike rational expressions. Let's look at a problem. Subtract and add 5 over x minus the rational expression 3 over the binomial x squared plus x plus the rational expression 7 over the binomial x cubed minus x squared. Okay, so we can see very clearly that these are all unlike rational expressions. They all have different denominators. So our first task is to make them like rational expressions. And the first task in doing that is to factor all of the denominators. So our first denominator stays exactly as it is. Our second denominator, we're going to rewrite x squared plus x as x times an x plus 1. The numerator does not change. And our third denominator, which has a GCF of x squared, will be rewritten as x squared times x minus 1. And again, the numerator does not change. Okay. We are now going to place additional factors top and bottom in an effort to make all of our denominators the same. This first fraction has an x. This one at the end has an x squared. Therefore, this first fraction needs a second x, so we place it top and bottom. This first fraction is missing an x plus 1, so we place it top and bottom. This first fraction is missing an x minus 1, so we place it top and bottom. Okay, first fraction is done. Second fraction has an x, but we need 2. So, times x top and bottom. Also missing an x minus 1, which we place top and bottom. Third fraction has the x squared, like this one and this one, has the x minus 1, like this one and this one, but is missing the x plus 1, which is placed top and bottom. Okay, now all of our denominators match. We're going to do a little simplifying here. So the first thing I'm going to do is I'm going to rewrite all of our denominators the same way. X squared, x plus 1, x minus 1. X squared, x plus 1, x minus 1. X squared, x plus 1, x minus 1. The next thing I'm going to do is I'm going to work with my numerators. So this numerator is a 5 times an x, which is a 5x, times an x plus 1 times an x minus 1. Well, if you remember your factoring formulas, x plus 1, x minus 1, is the result of factoring the difference of squares, x squared minus 1. So I can write that as x squared minus 1. Here I've got a 3x, which I'm distributing to these terms. And here I've got a 7, which I'm distributing to the x plus 1. All right, now we're going to do all of our distributions. Notice that we treat numerators differently from denominators. With denominators, we factor and leave them in factored form. But with numerators, we do things like multiply, distribute, and combine like terms. So in our numerator, we're going to have 5x cubed minus 5x over the x squared, x plus 1, x minus 1, minus a 3x squared minus 3x over the x squared, x plus 1, x minus 1, plus a 7x plus 7 over the x squared, x plus 1, x minus 1. Now we are finally ready to combine our three fractions into one fraction. We keep the common denominator, x squared, x plus 1, x minus 1. Now, when it comes to our numerators, we add or subtract depending on the symbol in between the fractions. So, for example, this 5x cubed minus 5x will be followed by a subtraction sign. And because the numerator that we're subtracting has more than one term, all of the terms must be placed in parentheses. 3x squared minus 3x. There is no such rule for adding. You can simply place the 7x plus 7 after the plus sign. Now distribute the minus here and here. And so we will have 5x cubed minus 5x minus 3x squared plus 3x plus 7x plus 7, all divided by x squared, x plus 1, x minus 1. Combine like terms in the numerator. The only term with an exponent of 3 is the first one, 5x cubed. The only term with an exponent of 2 is the third one, minus 3x squared. Then we have 3 terms where the x is an exponent of 1. That one, and that one. And when we combine all of those together, it makes plus 5x. And then finally, plus 7 over x squared, x plus 1, x minus 1. Now normally when we finish a problem of this type, we have to check and see if our rational expression can be simplified by factoring the numerator and the denominator. However, our numerator polynomial is acubic, meaning that its highest degree term is an exponent of 3. And at this level of algebra, we have not taught you any methods for factoring cubics. And for that reason, you may simply stop. This is your final answer. And with that, we're done with this problem.